Hello dear students, today we are going to discuss in this video about parallel plate capacitor. Parallel plate capacitor. Okay, so this is the most common and widely used, most common and widely used capacitor. Okay, now as per the name it suggests, it is parallel plate, means two plates are kept parallel to each other. Suppose this is one plate. Okay, let this be the first plate and this is the second plate. Okay, now this plate, the one side of the plate is earthen. This earthing has been provided, and a plus Q charge is provided on this first plate, and this plate is insulated. This first plate, plate 1, this is 1, this is 2. This plate is insulated plate. Okay, now what happens, because of induction, this end gets negatively charged. Okay, and this full plate is positively charged. And area of both the plates are equal. Area of both plates are equal. Now what will happen, since this end of the left end of the second plate is negatively charged, the other end gets positively charged. The other end gets positively charged. And since this is having earthing, so what happens, that the electrons gets supplied from the earth and this positive charge is neutralized. The plus Q on plate 2 gets neutralized because of earthing. So finally the situation becomes, in steady state, the situation becomes this plate 1 this is positively charged and this plate 2 inside is negatively charged. Okay, and what happens that, now as we have studied earlier in electrostatic, for infinite sheet, if this is a infinite charged sheet, at any point this electric field E is equal to sigma by 2 epsilon. So what will happen, this is plate 1 and this is plate 2. Now using this concept, we need to understand that electric field at any point P, so electric field at point P because of plate 1 is equal to sigma by 2 epsilon, and electric field at point P because of plate 2 is sigma by 2 epsilon, and this is positively charged, this EP1, I am drawing this P point outside so that you will understand. This is EP1, okay, and this will be, this point is P and this will be EP2, okay. So total electric field at point P, total electric field at point P is equal to sigma by 2 epsilon plus sigma by 2 epsilon, that is sigma by epsilon, okay. And the direction is, the direction of resultant electric field is from positive plate to negative plate, okay. Now E is equal to sigma by 2, E is equal to sigma by epsilon. Now the sigma we can write charge divided by area divided by epsilon, that is equal to Q by A epsilon. It implies Q can be written as E into A into epsilon, okay. Now using the earlier concept what we have studied about capacitor, Q is equal to CV, it implies this E A epsilon is equal to capacitance C into potential difference which is gained by the plates. Please remember, V is the potential difference gained by the plates till steady state, okay. Now from the earlier concept of electrostatics, E is equal to V by D, that is potential difference divided by D. Here only we are taking the magnitude, so we can write V is equal to E into D, so that is equal to C into E into D. So finally we can write E into A into epsilon is equal to C into E into D. So this E goes off, it implies C is equal to A epsilon divided by D. Now this is the formula for capacitance. This is formula for capacitance of a parallel plate capacitor. Parallel plate capacitor. Okay, where D is the parallel distance between the plates and A is the area of each plate. Okay, epsilon is the permittivity of free space. Now if instead of vacuum in between the plates, suppose the two plates they are filled with a dielectric medium. If they are filled with a dielectric medium, suppose this is a dielectric medium, okay, dielectric medium, okay, of dielectric constant K, then, and rest all the parameters are same. This is D and A is the area of the plate, okay. Then C is equal to K times epsilon A divided by D, okay. So what does this formula indicates? This formula indicates that if a dielectric medium is inserted in the space of the parallel plate capacitor, then the capacitance increases by a factor of dielectric constant, okay. So this is the basic concept of parallel plate capacitor.